recording anyways.
Okay, I'm gonna collect your 3-1 homework tomorrow.
My heart kind
So,
of there for a minute.
if you don't want to stay for class tomorrow, then you can turn it in to me in the morning. But if you want to turn it in 7th period in class, you can. Okay?
To Brody or to you?
To me. Or it doesn't matter. He'll bring them to me. Whichever you prefer. So make sure if you have any questions, 2nd period, 4th period, I don't have class, and right after school or homeroom. I guess that's not really the order. 2nd, 4th, homeroom, or after school. I guess Katie right. Today you could. Alright, you ready to talk about 3-2?
Sure.
Okay, product rule and sum rule. Okay, so you cannot. Alright, let's just do an example. Alright, let's let f of x equal x and g of x equal x squared. Okay, so if I want to find the derivative of these two multiplied together, how do you think we would do that?
You want the right answer? Because I looked in the book, or?
I don't want you to look in the book.
I want your
Well,
guess.
I already did.
Lucas.
Well, there was a multiplication problem in the last homework, so I had to look.
No, you could have done it a different way.
Well, I mean, you can do it either way, but I wasn't sure.
Yeah.
He made us do the long way.
So I did it both ways, and you get the same answer.
Yeah, because you could have done it by simplifying the exponents, but you did it using the product rule. Okay, well, Lucas just ruined my example. Okay, but basically, you cannot, this is not equal to, if you do the derivatives multiplied together, it's not equal to the derivative of each part multiplied together, was basically what my point was going to be. Okay? So, there's a rule called the product rule. You have a product rule and a quotient rule. So I just want to make sure you know this, that these are not the same thing. You can't just do the derivative of f times the derivative of g. Okay? So the product rule, so you've learned the power rule, and then now you have the product rule. So the derivative of f of g is equal to the derivative. Oh, they used e here. I'll do it like they did in the book. I'm sorry. Just so I'm consistent. Okay, that's equal to f times the derivative of g plus g times the derivative of f. So this is how it's written in your book. I just used the prime that I was talking about before. So like, I think, was it the last section that we did a problem that was like x squared of x? I think so. Something similar to that. So you could do this problem 2 ways. You could do this problem as where you combine the exponents, because this would be x to the 3/2, and then we did the power rule. Okay, so we got 3/2 x to the half, which is 3/2 square root of x. Yes? Okay, or you could do this using the product rule. Because the product rule says if I have 2 things multiplied together. So if I did it the other way, so this is how we learned how to do the power rule. Okay, so if I do the product rule, that means that my f of x is x, and my g of x is square root of x. Okay, so it says I would take f times the derivative of g. So my f would be x times, okay, I want the derivative of g. So if my g was x to the half,
Did you just switch gears? Like, we're not doing that?
Correct, because Lucas ruined it for me.
Oh, okay.
I was gonna show why this is true,
Oh, okay.
but then he goes, I already know the product rule.
Well,
So
he
I
asked how we would do it. I said, well, do you want the right answer?
No, I wanted you to like just tell me what you would have done before you knew the. It's okay. I'm not mad. Yes, I did switch gears.
Okay.
Okay, so I just switched. Like I think this is either a problem that we did in class or you did on your homework. I can't remember which one. Okay, so I was just showing how we did it. This how you do it this way, but you could also do it using the power rule. Or sorry, the product rule. Okay. So I did the product rule, I have f of x, and then I need to take the derivative of g. So the derivative of g would be a half x to the negative half. Plus, then the second part says I take g, so g is x to the half, times the derivative of f. Well, the derivative of f would just be 1. So this would have been a half. Then if I add exponents, 1 plus negative half is a half. Plus 1 x to the half is 3 halves x to the half. But you get the same thing, isn't that cool?
Seems like the second one.
It is for this problem. Okay, now, if you were doing something that had like x's and y's, or something where you couldn't combine exponents like we did here, then you would have to do the product rule. But if it has the same variables, the power rule is a lot faster. Okay. All right, you want to do like a couple complicated examples?
Yeah.
Well, this one's not really complicated, but I just want to make sure you guys remember how to do e to the x stuff. Do you want to call this example 1? So the next one will be 2, or this will be 1?
That's one.
So
And
this
the
will be
next one's two. Can you write one?
I will, there you go. Does that make you happy?
Yeah.
Bless you. I didn't really explain this to you, but I'm assuming you knew what that meant.
Yeah, it's like information.
Yeah, Ms. Baker, I was gonna give it to your dad, and I was in there, and I said, I'll just give it to her first period, because you had to sign it, and you had already went home. And that way your dad didn't lose it. So, is that fine? You're like, yeah, okay. Okay, is this what she said? Okay, so if I wanna find the derivative, can you do this on your head, or would it help you to write it out, like what you're supposed to do? Write it out, okay. So if I were to write out what I'm supposed to do, this would be f of x, derivative of g. So this is my first term, this would be like my f of x, and this is like my g of x inside the thing. So that means if I want to find the derivative, that would be x, and then I would do my d dx of e to the x. Right, because I want to do f of x times the derivative of g to x, plus g of x, which is e to the x, times the derivative of x. Okay, so what is the derivative of e to the x? Is that the one thing that you were always taught?
Because I asked her why she taught me, and she said because it was cute having a little 4-year-old running around college telling people calculus stuff.
Okay, so then I would have x times, you guys told me the derivative of that was e to the x, right? Okay, plus e to the x times, what's the derivative of x? 1. So this would be x e to the x plus e to the x, which you could leave your answer like that. Technically more simplified would be to factor out an e to the x, but like I wouldn't count it wrong if you left it that way.
Do we need to understand why the derivative of e to the x is e to the x?
No.
Okay. Because I don't understand.
You don't need to understand it. You wanna do one more of these or two more of these?
How difficult are they?
It's up to you. You can look.
Just do the merge.
Do one hard
Do you
one.
wanna do this one or this one? Okay, I wanna do this one.
Just do that one then.
Okay.
Yeah. Sure.
Well, I wanna do it because I wanna make sure you see a problem like it.
Wait, no.
Oh, okay, so when you're doing a problem like this that has it grouped together, you could distribute. So then you have like a product rule and then a product rule, or you could treat this whole thing in parentheses. This could be treated as your f of x, and that would be your g of x. Okay, or you could distribute and then do a product rule and then a power rule and then combine.
Which one's easier?
I would leave it in parentheses unless they all have the same variables. I would leave it as parentheses. Okay. So then if I want to find the derivative of this, I would do my f of x, so I would have my z squared plus e to the z. Then we're going to times the derivative of square root of z plus, then I have my square root of z, and I'm going to do times the derivative of z squared plus e to the z. Do you know the quotient rule yet? No. You just looked at it for a moment. Okay, so then if I solve this, simplify it, this would be z squared plus e to the z times, okay, so what's the derivative of the square root of z?
1/2 negative square root.
1/2.
Or to the negative 1/2.
Okay, so you can put it on bottom, right? So you do 1 over square root of z. Okay, so it'd be 1/2 z to the negative half. Plus, I would have my square root of z times, okay, so what's the derivative of what's inside here? So what's the derivative of z squared?
2z.
2z plus, what's the derivative of e to the z?
E to the z.
So then now you can distribute and combine like terms.
How'd you get half of z to the negative half?
So if I rewrote this, that's the same thing as z to the half. So then your power rule says you bring the half off,
Oh,
and then you subtract 1. Okay? Everyone else good so far? Okay, so then if I distribute, so distribute, I would have 1/2. Okay, so if I have z squared times z to the negative half, that's going to give me z to the 1/2, which is z to the 3/2. Plus, 1/2 e to the z, z to the -1/2.
Z is a number.
I'm sorry.
It looks like 2.
Okay, I feel
That's why I
like,
put a line through it.
but before you go on,
Uh-huh.
can you explain how you got the first term?
I got this one? Yeah. So when I distribute, so you're good with the half?
Yes, yeah.
Because the 1 in front of here and then times the half will be a half. Okay. So then when you multiply variables, you add exponents. So 2 and then a -1/2 would be 1.5. But then you just make it improper.
Yeah.
Okay? Okay, so if I want to multiply and distribute z, isn't square root of z same thing as z to the half? Okay, so then if I distribute here, this would be plus 2. Okay, then I have a z to the half times a z, which would be z to the 1.5, which would be the same thing as 3 halves. Okay, then if I do the last term, that would be plus. So z to the half times e to the z would be e to the z, z to the half. Okay, now we can combine one term has the same exponents. Z to the 3 halves. Okay, so if I have a half and 2, that gives me 2.5. What's 2.5 as improper fraction? 5 halves. Okay. Now, can I combine these two? No, because this has a -1/2 and this one has a +1/2. Okay, now if I simplify this, we'll have to simplify this still too, but if I simplify this, I would have an e to the z on top, and I would have a 2 z to the half on bottom. What's the same thing as z to the half?
Square.
Square. Okay. So then if I simplify the last term, that would just be e, z, and everything stays on the top, square root of z. Okay, now if I totally simplify, does everybody understand how I go from 5 halves z to 3 halves to 5 halves z square root of z? Yes, okay, because this would be z to the 1.5, right? So I would have a 1, which is here. And then I still have to have that half, which is the square root. Okay, yeah? Then this, I could make e to the z over 2 square root of z. Now, you could stop here, or if you wanted to make it all one fraction, you can get a common denominator. I'm assuming you guys would rather just stop.
Yep.
Sounds like a good idea.
Do you see why I wanted to do that one?
Yeah.
And like when I picked examples this time, I usually like try to do the ones in their section, but I'm like, well, those are for you guys to look at, so I just picked some of the odds, like one of the ones that aren't your homework problems. So like, well, so you have some odd homework, so I tried to pick ones that are similar but not your exact homework problems. Okay, does everybody feel maybe not great about this, but like this makes sense? Okay, so now we're gonna do the quotient rule. What's quotient mean?
Division.
Division.
You can't really not think about that.
You guys need to be more excited about math class.
Well,
Not unless it's
I'm getting that changed. Like I have have any control over it. I'm trying to get it changed.
I'm
I like
very
this
appreciative.
Oh,
Yeah.
heck.
Carly, what?
Because
It-
she
it,
gets
like,
to
makes-
take an hour of her life.
Did
Yeah,
you hear
because
about
I
the
can't
email
just
we got
after
yesterday,
school.
Mr. Boo?
Like
Do I need to stop the video?
Oh, sorry, I said that. I'll tell you.
Let's talk after. I want to tell you guys something else too.
No, I think I can do this for about these 3 weeks, but
This is 3 weeks. That's all we have left.
that's,
I feel like this like semester's gonna be really fast.
I'm so excited.
I was always really excited to graduate, but then I was also really, really scared to go to college.
That's
how-
Like I was really excited, but I was like super nervous.
I just think it's sad that we've grown up together and then we're never gonna see like most of each other ever again.
Yeah.
Okay, well,
I think that's sad.
You're so heartless.
You are.
It's because he's
I hope
ginger.
you start crying.
I already know I'm gonna cry at graduation.
okay, you will see the people that you want to see.
So
most
Lucas
of
is
you-
never gonna see me.
You'll see me
Lucas will
on
never see
Snapchat.
anybody.
Yeah, Lucas.
I didn't say that, you guys said that.
Joke's on him, because I'm gonna come stay behind him. I'm gonna show up. I'm ready for sleepover.
sure the Christmas time, see me and cookies.
Okay, so the quotient rule, so if we just put if f of x was on top, g of x was on bottom, you do g of x times the derivative of f minus f times the derivative of g divided by g squared.
But yeah, it's fine.
And you guys aren't doing too bad on your test.
Really?
Have you graded mine yet?
I've just looked at them and like I'm going through them slowly, but like question at a time. But
That's good though.
the parts that I knew that you should know because I knew I taught you or Miss Reese taught you, you guys are doing really well on. So.
I feel like our only problem is we just didn't see like a large amount of problems.
Yeah.
Like, and if we did see them, we didn't know how to do them until Miss Draper told us how to do
Did
it.
it
Right.
Told us
step
the
by
answer
step.
instead of telling us how to do it.
And I know you didn't, I know you guys said you didn't talk about Half-Life, so I'm gonna do a little lesson over Half-Life.
Mr. That Urban guy
Mr.
said
That
that he
Urban
doesn't know
guy.
how we're gonna do it without a calculator.
Who said that?
That Urban-
Brody.
Oh, you can't, because they're exponential functions.
Well, then how are we supposed to do it on the test?
This one will come out where you could have it as, you don't have,
Trust her.
you could set them up like logarithms, but not actually get to the answers. Set them up like an exponential, but not actually get to like what the actual,
I
do you
don't-
know, like let's say you had like, we talked about that, I think, was it this the problem I gave yesterday where we were showing how to convert? So if you had to solve this, you could tell me that this is your answer. You don't actually have to find what that value is. Or if you got your answer was this, you don't actually have to tell me what that is. You would just leave it. Okay. Half-Life deal with exponential functions, in case you didn't know.
Sweet.
So if you had to go to the exact answer, you would have to use a calculator. But you could leave your answers.
So is it okay if I put the exact answer on the test?
Yeah, that's fine. I'm not mad.
Thank you.
Anything goes until I go to IU and they tell me what it doesn't go.
Oh.
Okay, so you have till December 12th. December 13th. I
That's
guess.
when our money is due for this class.
Okay, and you guys have until, oh, I was supposed to tell you this. You guys, this is a year-long course. You have until April to withdraw. You don't have it like, I think Ms. Reader kept saying it was like
Yeah,
next
he
week, like
said
December
it
7th.
He told us the other day.
Yeah, we had to sign a paper too.
Okay, but, yeah, because you were supposed to sign that in October. It was seriously due like the second week of October, like during fall break. I don't know if I can sign it before. What was I gonna say? Because you guys are taking calculus over the semester, you're taking over a full year, you have until April 19th to withdraw. Where like my pre-calc guys only have till December 7th. Okay, Side
I
note.
can't imagine doing all this in a semester.
But you'd have to in college.
You kind of almost are, except for the first 2 chapters.
Lucas, what?
Well, so we're gonna have to end up doing all of it next semester, because we didn't get very far.
We're gonna get there, Carly.
Maybe
You're not
the
be
first 2
positive.
chapters.
We're already on the
Hey,
second section. It's only been 3 days.
The positive part is we're just gonna have less to forget.
Exactly. There you go. Look at the positive.
Or we're just
Okay.
gonna have to remember more.
If I want to find the derivative of this, this would be gx. So my g of x is your denominator, so x cubed plus 6. And then we're going to multiply that by the derivative of the x squared plus x minus 2. Okay, now keep in mind when you're subtracting after this is multiplied together. So you might want to put like some brackets around it so that you remember. Okay? And you're doing f of x, which is x squared plus x minus 2, times the derivative of x cubed plus 6. And then this is all divided by x cubed plus 6 squared. Do you like how much work calculus is for one problem?
Love it.
Yeah, just fine and dandy.
Did you like my sarcasm there?
Yeah, okay.
Great.
Breathing.
What?
Great. Positive. Let's be positive. Okay, so x
I am
cubed
positive.
plus.
You're teaching calculus, and I'm very happy.
Okay, thought somebody is. X cubed plus 6. Okay, now I have to find the derivative of x squared plus x minus 2. So what would my derivative of that be?
2x plus 1 minus 0.
Yes, good. So can I just put 2x plus 1?
Yeah.
Okay. Minus. Then I would have the x squared plus x minus 2 times, okay, now I want to do the derivative of x cubed plus 6.
3x squared.
Good. Plus 0, is that what you're going to say?
Yeah.
Good job. Good job, Faith. Divided by x cubed plus 6 squared. I didn't move my camera back.
Oh. Yes.
Sorry, Chloe.
Math.
Ooh, I'm sorry. That's okay, you can still see it. Okay. Now what are we gonna have to do?
Simplify.
Yeah, okay, so now, don't worry about the bottom. Don't like FOIL that out. So the top, distribute and then combine like terms, but don't just try to like distribute this. There's no point. Okay? So if I distributed on top, this would be 2x to the 4th plus x to the 3rd plus 12x plus 6. Does everybody agree?
Yeah.
Okay, now you know how there's this minus sign here?
Wait, how did you get that?
So x to the 3rd times 2x.
Oh, okay.
I can stop that? Okay. So, I'm gonna keep going. It's like, okay. Alright, so this minus sign means when I distribute this, make sure you make everything negative. Or if it's negative, turns positive. Okay, so 3x squared times x squared is 3x to the 4th. But this would be minus 3x to the 4th. 3x squared times x is 3x cubed. That's going to be minus 3x cubed. Okay, and then this is 3x squared times negative 2, which is negative 6x squared. So what is that going to turn into?
Positive 6x.
Positive. Over the same denominator. Okay, then all you do is combine like terms. So what would I have if I went for standard form? So highest exponent to lowest exponent.
Negative x to the fourth.
Negative x to the fourth
Minus
Minus 2 x to the third.
minus 2x to the third
plus 6x
plus 6x squared
squared to that plus 12
plus
plus
12x
6
good over
x cubed plus 6 squared. That's it?
Yeah.
Oh, yeah.
That's it.
So
all
why?
these years of having to simplify and all that, we don't have to anymore. Like really.
I mean